we are going to find as we move along in here that there will usually be several ways we can solve something. With radicals, it's no exception. What we're going to do here is we just got done with our part on graphing radicals. Now we're going to use that as an opportunity to be able to actually solve a system. Now, I'm going to be honest with you. Okay, so up right here, notes this side. The actual assignment's going to be on the other side. When we're doing these, I purposefully make them come out as whole numbers to let you see where it is and have them come out correctly. Okay, that does not mean when we're doing these that you don't need to graph them at all, go straight to algebra and say, yep, I'm done. Because again, this is your opportunity to get it in a nice format so you can get a little bit of practice. So, the only way, bless you, we're going to be doing solving radical stuff in this first unit, well, this unit, is going to be by graphing. So here's how I would suggest tackling it. What I'm going to do with my colors, or you could label it like 1 and 2 if you wanted to, that's fine. So if you were going to, maybe go to the calculator and use the same thing, maybe we label them Y1 and Y2. What we're going to do is we're going to graph each of these things, and then once we graph it, we're going to look to see where they intersect. They may intersect at one place, they may intersect at several places. They may intersect at no places at all. So, when I look at this first one, I say, hey, that looks like my parent graph. Now, if I remember my parent graph numbers for square root of x, again, good practice if you didn't before, my parent values for my square root of x value were 0, 1, 4, and 9 for x, because again, those are my perfect squares, and their square roots, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. There is my parent graph. And since there are no shifts, up, down, left, right, no coefficient in front, those are the 4 points that I would use to graph my function right now. Again, make your dots kind of big, because what we're hoping is going to happen is one of the dots I make from this function and then one from my other one is going to be intersecting. Right. Now the second one, you may be a little confused. You're like, wait a minute, it just says 2. How do I do that? Well, remember that 2 is the line y equals 2. And whenever we see a y equals line, we talked about this when we were graphing lines, you're going to get a horizontal line at that value. So what I would do in this case is I'd go up to where y is 2, I'd put a dot, and I'm going to make a horizontal line through it. And if you're not doing colors, maybe you label them, y1, y2, so you can see later what's going on with that. And what you'll notice, or at least what I hope you'll notice, is that there's going to be a point, at least one, where they intersect. And whatever that value is, the x value there is my answer. So the x value, or it could be values, of my intersection is going to be my solution. Thank you. It'll always be the x value. It will not switch up sometime and be the y value. And if I take a minute and I think about it, I'm like, well, I probably could have figured that out in advance, Square root of 4 is 2. Okay, that matches up. That works. But again, part of this is the practice with graphing as we go. So as we see more things where we need to graph, we can do that. But that's basically how this is going to work. So I personally would kind of keep going the color route here. And even if you're just taking the dots and plotting them, that really would be enough. Now this time, though, I've got a shift. What's my shift on this one? What direction are we going 6? left. So like we did before, there are my parent points. I'm going to make them really tiny here. So 0, 0, 1, 1, 4, 2, 9, 3. Because I just want to be able to see them enough that now I can go and move them all left 6. 6. And then we'll make these dots bigger. 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, so that would be the graph of my line x plus 6. And I'll label these again as we do them. And then here it's just x. Now, here again is where I got to be a little careful. It's not a number like this, so it's not going to be a flat line. If I'm looking at this, maybe in slope-intercept form, it seems like it would work something more like this. Hey, my slope is 1 over 1, because there's no number in front of x, but there's a plus 0, which means my y-intercept is at 0. Then I go up 1 and right 1. Up 1 and right 1. Up 1 and bingo! Up 1 and right 1. And I make a few more, but I already see where my intersection is. My intersection's right here, which is, looks like 3. Let's see if 3 makes sense. 3 plus 6 is 9. The square root of 9 is 3. Yep, that makes sense. And I get my answer. So with all of these, that's one of the things I'm trying to do as I do these is, you know, get my practice in there, plus it's giving me an opportunity algebraically to be able to check my answers out and see how it's going. Because this isn't just a number. Okay, this has an x. So this one is the one where I am going to use slope and kind of go. If it's just a number, there's really no slope for me to plug in. Because if I plugged in a value, let's say I was making a chart here. And the question is, you know, why is this one horizontal and why isn't this one? So if I was punching this in on a graphing calculator, y equals 2, and I was plugging in some values for x, there's no place for me to plug in the x value. So the number's going to be the same no matter what x value I'm plugging in. When I get over here, though, if I were looking at a chart on my calculator with y equals x, I can literally plug this number in for x, and it's going to change as I keep going. And so when I'm doing that, there's 0, 0, there's 1, 1, there's 2, 2. Why my graph's going to change a little bit. So when it's x, it changes. If it's just a number, that's the only time it's going to be a flat line. Very good question. Very good. Any others before we jump to our next one? Because we're going to twist things just a little. What's that? That's just me drawing an arrow with my blue here to where that intersection point is. Because when you graph your two lines, there's usually going to be at least one, maybe more points where both of these lines, this line and this line, have an exact point that they share in common. So whatever that point is that they share in common, the x value of that point is going to be the value that I'm looking for. So it's even more important with these that I'm being very accurate with my graphing, because if I'm off by a point, I may miss the intersection completely. Yeah, and that's one we'll have to take a peek at and see what went haywire on you here to see how this goes. Now 3, notice a change. Now we've got a cubed root. So what I'll do here in a minute is I'm going to break out the calculator for the first time to kind of give you some options here. But I'm going to keep labeling these. Because again, even if you don't have colors sometime, or maybe you don't have a graphing calculator, I want you to be able to tell the things apart. So when we're doing a cubed root, reminder, my parent graph with cubed roots. And it's still something you've got to work on getting into memory because it makes life so much easier. My perfect cubes can go positive and negative. So those would be my, whoops, that would not be correct, that would be, are going to be my parent points. This is the graph that looks more like a snake. And I'm just going to plot my points here. I notice that there's going to be a shift, so I'm going to do them really small with those 5. But then I've got to look and see, okay, what am I going to do with those points? Because I've got to shift this time. So I look here, and I go, okay, that's going to be right too. So I'm going to take all my points, and as I shift them right too, I'm going to make them kind of big. Knowing that more than likely, one of those 5 points that I just plotted is probably going to be where the answer is. So now I look at the right side. And I go, oop, there's one that's just a number again. So this is going to be another one that's a horizontal line. So I go to where y is 1, negative 1, excuse me. And I get that in there. And again, I notice, as I follow that line along, right here is the point that both of my lines share in common. And once again, I just want the x value of that. And then I can check. 1 minus 2 is negative 1. The cubed root of negative 1 is negative 1. Yep, that one worked. So a lot of times you're only going to see one value that's the same, but that may not always be the case. Uh-huh. Yeah, because the answer comes from where my 2 graphs intersect. Because you're right, when I plug it in, 1 minus 2 is negative 1, and that's the answer it gets out. But if I plugged in any number here besides positive 1, the 2 sides wouldn't equal. That's kind of my double check way, is using the algebra to double check and make sure that it's working okay for me. Yeah, well, it's not that I'm changing anything, because it's where those 2 lines, my green and my purple, that one point that they're the same, it's just taking whatever x value is there. Yeah, it just so happens that when I plug it in, it's changing it to a negative. It's just, mathematically, it's how it works on that one. Now, this one might blow your minds, though. We get to 4, and we go, okay, looks like on my first one, it's just my base graph for a cubed root. So it's basically, it's just going to be, these are going to be my actual points on this one. So I can go ahead and make all of those points large the first time through. We've also graphed that second one before. Because again, when this is y equals x, it's like that 1 over 1x plus 0. Which means my graph starts at the origin. You're like, well, there's my answer. I don't even have to think anymore. Keep graphing. I'm going to go up 1 and over 1. You're like, wait a minute. Now I got 2 points. So if I keep going up 1 and over 1, you're like, okay, at some point I'm not going to connect with anymore. But what if I go the other way too? So if I go up and right, and I'm like, I'm not going to get any further because I look at my other graph that I already made, and I'm like, yeah, they're not going to connect anywhere. So I go, instead of going up and right, I go down and left. Dang, there's another one. So you're like, wait a minute. So this one they matched. This one they matched. This one they matched. So it is possible that I could have 3 answers? Well, let's see. The cubed root of negative 1 is negative 1. The cubed root of 0 is 0. And the cubed root of 1 is 1. So yeah, I can have lots of answers. I can have 3 answers, or 2, or 1, and kind of look at them that way. So again, it's going to come back to graphing and looking to make sure that you're being accurate. Like I said, even if you don't want to connect the dots, if you just want to make dotted lines for these to be able to see where those intersections are, there's nothing wrong with that. I started at the origin at 0, 0, because if I was putting this into slope-intercept form like we did up here, that would be the form that I'm looking at. So this would be my starting point, starting at 0 on the y-axis, and then going up 1 and right 1. But then I can also, again, do the double negative here and go down and left to make that line. Just keep telling yourselves, this is the line I'm trying to create. And if you really want to, if you're like, okay, I'm not sure on this, you do have the option of grabbing a calculator and using the y equals function. So like, let's say on this one I wanted to check that way. So I was going to plug this in. Okay, so I go to y equals. Remember, when I'm going to plug this in, if I don't want to do a bunch of extra button presses, I can take this to the 1/3 power. Okay, that would be my first line. And then I could arrow down to my second one and type in x. So what you would do in this case, if you went to the calculator, is you'd pull second graph. You'd want to look at your table. And what you'd be looking for, because here's all my points for the cubed root of x. Here's all my points for y equals x. You're looking for where the y values are the same. Okay, they're the same right here. So one of my answers is -1. They're the same here. Okay, if the y values are the same, that x value is an answer. So 0 is an answer. And then I get to the last one. 1 and 1 are the same. So 1 is an answer. That's another way you can do it. You just type each one in its own separate line, like we did here, and then pull up your chart and look for the y values to be the same. So there are options on this. It's not just going to necessarily be that one thing. Then we throw a twist in. Yeah, we may have to work on the graphing part with some of you here to make sure that we got that part going okay. So I get to this next part, and I do want to make a note here in the middle. We're going to attempt whenever we can, we're going to try to get the radical alone by a side on itself. It's just going to make our lives easier. So in this case, okay, here's my square root of x. If I want to get that by itself, I'd minus the 2 to the other side. So if I went that route, I would type this one in the calculator for y1 if I wanted to, and we can use the square root button. Otherwise, you could use x to the 1/2. This is going to be my second one. Now again, whether you want to do the calculator or you just want to do it with your parent graph, it doesn't matter to me. I know the square root of x is the same one I used up in number 1. And without the shifts or anything, I know I can plot 0, 0, 1, 1, 4, 2, and 9, 3. And maybe I just leave them as points for right now until I get my other one's graph. So maybe it jumps out at me a little more on what this should look like. This guy, I know a y-intercept this time. My y-intercept is going to be at -2. So I go down 2, put my point, and then I know my slope, if I don't see 1 ahead of x, is going to be 1/1. So starting here, I go up 1 and right 1, up 1 and right 1, up 1 and right 1. And when I go to make that next point, Now I notice, well, now I'm putting a dot where I already had one. And if I were to keep going, but right here, that's where my two colors overlap, where my two lines overlap, my two graphs. And so my x value there, come back down to the x-axis, is 4. Does the square root of 4 equal 4 minus 2? Well, last I checked, 2 does equal 2. So that's correct. And I've got myself the right answer. So that's not, not bad. Again, calculator will get me to the same thing. Last one. And it's double starred for a reason. When we're trying to work on getting our radical by itself. So let's say I minus my 3 out of there. Now, I'm doing everything right. I get that written in. You're like, okay, nothing looks too weird so far. Maybe. So I get ready to graph this. I notice there's a shift. I've got a shift on this one of right 4. So I look and I go, okay, let me move my little dots first. Because again, at this point, notice we've already on, this paper done a base graph for square root 4 times. If you do 4 more on your own, it's going to start clicking on where these numbers are at. I'm telling you. So now I'm going to take all these, I'm going to move them right 4. 2, 3, 4. I'm going to make bigger dots. Kind of off my chart here. Okay, so I put little dots for the other ones. I can see these 4 big ones telling me where that's at so far. So then I look at my other one. It's just a number. And we've seen here when it's just a number, we go to that y value, -3. And I draw a horizontal line. But you're like, well, wait a minute. This is just graphed up here. This is just graphed down here. They don't cross anywhere. Like there's a big gap in there. Well, what do I do then? Well, if they don't cross, I don't have a solution to it. Now, if you noticed early in this one, even though we're going to graph them, I can't take a square root and get a negative number. I can get 0. I can get a positive number, but I can't get a negative number. So that would have told me right away this was going to be no solution, but we like to doing the graphing anyway just to make sure that everything is going right, that's on the up and up with this. But again, if you're more comfortable using the calculator on the square roots and the cubed roots, punch them in your calculator. It's okay. But you do need to graph them. So what I'm going to kind of throw your way on these is going to be on the back side of this sheet. Because as we look over here, this is going to be the actual assignment, these 4 on the back. Now, here's the nice thing about it. You can't get rid of your note sheet because the note sheet's stuck to it. So flip them back and forth. Try using those. Try doing the graphing. Check your answers. And if it's not working, let's chat. But do not come up with a blank and give me the shoulder shrug. You've got to try something based on what you see, whether it's just typing them in the calculator or parent graph and shift them. Don't care which, but you got to try one of them. Okay? So